We're back in the basement at Jake's house with Craig Novak, the project manager for Jake's house. And today we're talking waterproofing. Let's get to it. We've all been in basements where it's just an uncomfortable place. It's obviously below ground, it's damp and cold and just not a great living space. Today we have the technology to build different basements. And today we're gonna have Craig Novak walk us through the steps that we've made to make this basement at Jake's house an incredible living space and forever waterproof. So Craig, let us know what's going on, because there's a whole lot going on here.
Well, initially we created a pan on top of our isolation foam and gravel, and that was the area that we then tied all our rebar to pour into a space for our mat slab. From that point,
so we basically made a bucket out of this membrane, which is really sitting behind us as well, and then filled it with concrete and rebar.
Correct.
Okay.
And then from that point, these forms were made for our basement walls. The mat slab insulation or waterproofing only came up to about 18 inches to the top of the mat slab forms. So then we proceed to integrate that into the furtherance of our waterproofing up the sidewalls. There's a great example of raw concrete and then a primer up here on the wall. That's applied so it creates a tackiness for the material to hold very fast.
So we basically put this greenish glue on the walls, and then we're putting this waterproofing on top of that.
Correct.
So did they just, after they poured the walls, which happened I think last week, did they just put the glue up right there and then put the membrane up, or did they have to prep these walls?
These walls had to be prepped. So there's small snap-tied holes, which you can see these impressions, that it had to be filled so we have a smoother flat surface instead of a conical indentation for the form ties.
Okay, so this has all been smoothed out with those little holes that were formed.
Yeah, and some minor grinding just to create a more uniform surface.
And so why is that important here?
You want this to adhere quite tightly so that it is able to take up the next layer, and then all the overlaps are very tight because they back roll, and if they had voids, they wouldn't get a high cohesion at those points.
So really what we're making is a bathtub out of membrane.
Correct.
And the basement is itself not waterproof, right? Concrete is actually freely permeable.
Yes, there's additives you can put into the concrete, but then you're adding a chemical base to the concrete, not guaranteed, as these materials are guaranteed for many years by the manufacturer, and then the installers that are here on site today, putting the primer, adding these layers, have all been trained by the company so that they'll extend that warranty for the homeowner.
Okay, so not only are these materials specifically designed for waterproofing the house, but these guys that are installing this have actually been specially trained by the factory that makes this material to install this material.
Yes, according to their parameters. And they also come out and verify that all the steps have been made.
Okay, and then is there a portion at which the manufacturer comes out and actually says this was done exactly as it should have been?
Yes, yeah.
So then they are basically giving a warranty to the homeowner, stating that this was all done and they get their 25 or 50-year warranty or whatever it is?
Yes.
Okay, so is this the last step? I mean, we only have this membrane kind of going up about 4 feet or 5 feet.
So this material is a very heavy mill material, which is similar to the one that went underneath the slab.
So this is thicker than like a vinyl like tarp or something you would see.
Yes, much thicker. And this bound to the lower level. So there's quite an overlap, the thickness of the mat slab. And then the secondary materials would be running from the top of the wall and overlapping on a continuum, but not as thick as material as this.
So there's actually another layer that we're gonna go see in a minute that's actually comes down over the top of this as kind of an additional layer.
Yeah, so the tacky primer's on the wall. This has a tacky surface because they've removed the protection layer, and it's ready for them to start running the vertical pieces.
Okay, well, let's go look at that.
Great.
All right.
So as I was saying, there around the other side, around the corners, we're going to add these layers and then do quite a bit of an overlap. This secondary layer over the mat slab of the blind side material came up to about 18 inches. And then the overtopper was about 3 feet. And then we add this layer, which comes down from the top. It's much thinner than the blind side that was at the base.
So we really have 3 layers of waterproofing overlapping each other on this wall.
from this point downward. And then from here, it's only a single layer, but then this is the overlap. It actually has a binding layer of this real tacky material. It's much more than what is under the rest of the sheet.
Okay.
And that gives us that real nice seal where the overlap occurs.
So this looks like asphalt. Is this an asphalt-based membrane?
This is a bitumen based, yes,
Okay.
Maybe oil product.
Okay. And so this is basically impervious to the water, and the water would really basically have zero chance of getting through here.
Correct.
But we're really not depending on this being our last resort for waterproofing, are we?
Not at all. We will be adding our insulation layer, which has some water resistance, but on top of that, there'll actually be a protective layer of drain board, which is a dimpled, rigid polyethylene board with a filter fabric, so soils don't get in there and fill up those voids.
Okay.
So water coming through the gravel, which is where most water will drop to this gravel to underground piping, that water at its last resort would hit that board and drop. So very little chance this will ever see live, active moisture.
Okay. So once that drain board, which is non-perforated, right? It's a solid polyethylene drain board with the fabric, and it's got an air gap. So that's similar to an air gap that we see on the siding above houses.
Correct. Yeah, like a rain screen.
Yeah.
So it's just an underground water screen. So
Okay.
you're able to take water coming from any direction around the house, bring it to the basement or beyond the basement, because we have a tapering gravel set all the way to the lower part of the property, where we then go into a sump and pump out
Okay.
the water that's not been able to hit the surface.
So then do we pile the dirt that we're going to use to backfill this hole and make sure the ground is level or outside the house? Is that packed right up against that drain board, or do we actually have a whole nother layer?
On this job, we're actually using a conveyor system to backfill with gravel to probably 9 feet. And that will be absolutely a body of mass that water can flow through. And then we cap it with soil so that we have a landscaping medium.
Okay. So really water that came from this wall right here, maybe there was an underground river. It came here, it would actually hit that gravel, and because there's no absorption of that water in that gravel, it would actually fall down to the gravel down here, which would then flow underneath the concrete slab all the way to the drain on the other side of the house. So really we have the gravel, which is called a French drain, then we have the drain board, then we have the insulation, then we have a triple layer of waterproofing before water can ever get inside the house.
Yes.
Is that overkill?
Yes. But we want to guarantee that we don't have any moisture on that interior, because moisture is the problem that lots of houses have, where they get hot and cold surfaces with moisture vapor that can't escape, and then you get your molds and problems.
So you said it's overkill, but what would be, so say we didn't do all these steps and maybe we only did one, but then at some point 25 years from now, what would it cost us to go back and have to redo all this or fix that?
With the limited access around this property itself, it would be a lot more than what we're doing today.
So this is really kind of buying insurance to the quality of the house, the quality of the life that the homeowners get to live inside the house, because we're spending a little bit more money now assuring that they'll never have a water problem inside the house.
Correct. Yeah, it's very cheap insurance when it really comes down to it.
Okay. So again, building science is about cost effectively using money to make sure that we're building houses that will last for generations. If you're interested in learning more about this project or learning about other projects or building science in general, please hit subscribe as we show you how to build a better way.